Today what we're learning about are how to solve equations with fractions. We did some fraction work before, right? And we've also done some work on solving equations. So now we're kind of combining the two, all right? So some important things I want you to write down, okay? The first thing is if we have mixed numbers, we want to convert any mixed numbers into improper fractions. Okay, so that's what we're going to start out with if we have mixed numbers. Okay, then the next thing we're going to do is we're going to multiply each term by the LCD. You guys remember what LCD stands for? The least common denominator, right? So, for example, if I had these fractions, if I were trying to determine what the LCD was, I'd be looking at 3, 6, and 4, and I'm trying to find like the number that each of them can either turn into or divide into evenly, right? One way I can think about it is thinking about what are some multiples of 3. Like multiples of 3 would be 3, 6, 9, 12, 15, so forth, right? What are the multiples of 6? 6, 12, 18, 24, right? What are the multiples of 4? 4, 8, 12, 16, so on, right? Okay, what's the first multiple that they all have in common? 12. This one has 12, this one has 12, this one has 12, right? So that's how I find the least common denominator, okay? So the least common denominator is going to be 12 for these. Now what I'm doing today is I'm taking my equation and I'm going to multiply each term by whatever I decide is the least common denominator. When I do this, I multiply each term in the numerator. So I'm going to show you guys an example right now. Okay? And the reason why I want to multiply in the numerator is because that will help me to make the equation not have fractions anymore. How many of you love fractions? Like you love working with fractions? You're like, Miss Miller, please give me a problem with lots of fractions in it because I love them. Who says that? You guys dream about fractions at night? No. Yay, we're going to do fractions tomorrow in math. Like no one does that, right? You guys hate fractions, most of you, okay? So, yes, boo on fractions. We're going to get rid of all the fractions so the equation is easier to work with, okay? All right, so here you go. Here's your first example. Example 1. Let me move it up so you guys can see it a little bit better. Okay, so in this problem, you see there's lots of fractions, right? Everyone's going to cry. There's too many fractions. We don't know what to do. We feel overwhelmed. Our brain's going to explode, right? Okay, so the first thing we're going to do is we're going to get rid of all the fractions. Now I'm going to check first, were there any mixed numbers? Because that was the first step. So are any of these mixed numbers? No. Okay, so I don't need to do this first step that I wrote down, okay? But What I am going to do is I am going to determine what is the least common denominator, and then I'm going to multiply each term by that. So I'm going to look at my denominators. 3, 2, 2. And the denominator here is really 1, so I don't have to really take that into consideration. But for 3, 2, 2, what would be my least common denominator? 6. Okay, so I'm going to use 6. What I'm going to do is I'm going to take my equation and I'm going to multiply both sides by 6. Because remember, if I do the same thing to both sides, that's keeping it equal. Now, in order to do the same thing to both sides, I have to do it to the entire side on this side. So I'm multiplying 6 by every single part on this side. And I'm multiplying 6 by every single part on this side. Okay. So I've multiplied this whole side by 6 on the left. And I've also multiplied this whole side by 6 on the right. Okay. Now, what's 6 times 2? What's 12 divided by 3? 4. Was there a K with that? Yay! It's not a fraction anymore. What's 6 times 1?
6.
Divided by 2?
3.
Yay! That one's not a fraction either. What's 6 times 1?
6.
Well, that one was already not a fraction, but it's still not a fraction, right? What's 3 times 6? 18. Divided by 2?
9.
Not a fraction. Boom. Did we just get rid of all the fractions? Okay. Now I know you guys are like now really excited, like, yay, now we get to solve the equation. Okay, still not excited? All right, it's okay. All right, we're just going to finish the problem. It's a lot easier to work with now, though. Okay, so negative 3 plus 6 gives us what?
3.
Positive 3. Okay, which one's the constant? 4 or 3? 3, so let's get rid of that by using an opposite operation. Okay. Now, some of you guys right now are like, oh, we were so happy we had no fractions. And now, when we divide, what's happening? Uh-oh, the world's going to end because my answer is a fraction. It's okay. It's just a fraction. Okay, the world's not going to end. The sky's not falling. Zombie apocalypse is not coming. We just have a fraction answer. Now, the world will end if on your quiz or your test you don't do what to this fraction?
Simplify.
Okay, so what are we going to divide both of these by? Okay, so when I divide the top by 2, what do I get? 3. And the bottom by 2? 2. Okay, so this, everything in the world is right now. We have a simplified fraction for our answer. Okay? Are there questions on that? We need to make sure we reduce in the end, right? To get the right answer. That's like super important. Okay, if you forget to reduce, it's going to be wrong or it's going to be like a half credit. Okay? All right. Does anyone need more time writing this one down? Everyone's good? I hear a lot of crackling water bottles, so if you have a water bottle, can you just set it down on the floor so it's not crackling and it's not making me annoyed? Okay. All right. Let's take a look at this next example that we're going to do together. Okay. This is example 2. It did take up a lot of space, didn't it? Okay. Okay. Okay, so let's look at this one. Okay, we're going to review that very first step we wrote down. What did that very first step say? No, not that one. That's from a long time ago. Yeah, convert any mixed numbers. So do we have a mixed number here? Okay, let's convert this. Okay, that's what we want to do first. Okay, so do you guys remember how? Denominator times the whole number. So that's what? 21 plus the numerator is 27. So I'm getting 27 over 7n for that conversion. Now I'm just going to bring everything else down into the equation, written the exact same way that it was before. Okay. Okay, so now that I've converted, now I can look at, okay, what's my LCD? So I have these numbers, 4, 7, 1, and 4. 28. Okay, so the LCD is going to be 28. So I'm going to use that number and multiply in the numerator to every single part. Even this n, even though it's not a fraction, it's still getting multiplied by 28. Okay, I have to do it to every single part, every single term of the equation. Okay, so now I've multiplied both sides by 28. Okay, now if you can't do this in your head, use your calculator to help you. Okay, 28 times -3 divided by 4. What does that make? -21? Okay. Now I'm going to do the next one. 28 times 27 divided by, what's in the denominator on this one? Divided by 7. There's 108 n's, because you got n there. Okay, 28 times n? 28n. Okay, now this one, 28 times 17 divided by 4, 119. Okay, so now this is an equation that's more manageable. So what do you guys want to do first to solve this one? Do we have variables on both sides? Should I maybe move one of these? Which one do you guys want to move? 28. Okay, so we'll move 28 by subtracting it. We're going to move it over to the left side. We're going to make sure we put it under its like term with an n. Okay, so now we get -21 plus 80n equals 119. Okay, from there, which one's the constant over here? Which one? -21. Okay, so let's add it to get rid of it. Okay, so now we're getting 80 n's equals 140. Okay. What's last? Does 80 go into 140 evenly? Oh no, we have a fraction answer. So what are we going to have to do with this fraction answer? Simplify. Make sure you reduce it. Okay, I want you guys to think of what's the biggest number that can go into both of these. 2 can go in. Is that the biggest number though?
20.
10 can go in. What else can go in?
20.
20. Okay, let's divide by 20 because that'll make it a lot less steps. So now, what do we get when we divide by 20? Is that reduced? Yeah. There's your answer. Okay? So to review what we did on that one, we converted the mixed number. We looked at all the denominators. We determined what the LCD would be if we were trying to make one. We took that number and we multiplied only in the numerator on every single term to get rid of our fractions, right? Once we got rid of our fractions, we solved it using what we've been practicing, right? Okay, questions on that one? Okay. All right, take a look at this one, and I want you to think about, as you're writing this one down, why this one looks different than the previous two. So what is different about this one than the last two problems? Okay, does anyone have any thoughts? Raise your hand if you want to share something that you see that's different in this one. Hannah? There's distributive property. Okay, so if you get one where there's distributive property, let's distribute first and then we'll go through our steps, right? Because you guys have learned about distributive property before, right? It just means we're taking this and multiplying it by each of these, right? So the left side's going to stay the same. And the right side, what's 2/3 times x? 2/3 x. Okay, what's 2/3 times 4? Well, remember, you do the top times the top, so it's 2 times 4? 8. And then you do the bottom times the bottom, so it's 3 times 1. 3 times 1 is 12? Oh, it's 3. 3 times 1 is 3. Okay. I thought the world was going to end if 3 times 1 made 12. Yeah. So that, though, is a common mistake, right? Is like saying, oh, I have to multiply 3 times 4 also. No, there's a 1 in the denominator, remember? So 3 times 1 made 3. Yeah? Okay. All right, so now look at all your denominators. 1, 1, 3, 3. What's your LCD? 3. Yeah, if you only have 1 and one other number, the LCD is just that other number, right? So we're going to take the LCD, 3, and use that number and multiply it by every single part. Okay? So 3 times 2x. What's 3 times 2? 6. Okay, 3 times 7. 21. Okay, over here. 3 times 2 divided by 3. 2. Over here, 3 times 8. Divided by 3. Some of you can see these just like cancel on the diagonal, right? These, right? Okay. All right, so now we have a nice, friendly, non-fraction equation, right? Okay, so what should we move? 2 with the x? Okay. Okay, what next? Okay, what next? Divide by what? Okay, check. Is it reduced? Yeah. Okay. All right, are there questions on that one? Okay. How many of you guys need more time writing anything from there down? Like getting caught up? Okay, because I have to turn my page, so are you guys ready? Okay, on all these, see how I'm going on to like a new page in the notebook? The new page in the notebook, you can still call it page 12. It's still the same topic, okay? If you want to call like it 12A and 12B, you can do that if you start a brand new page, okay? But it's still topic number 12, so we want to have it labeled with 12. Yes?
Mine is going to be a little different.
Because you started late. Yeah, but whatever page number you started on today, that, like, if you continue to a new page, that's the same topic. Does that make sense? Okay, so I have one more that I want you guys to look at. And if you feel like comfortable and you want to try starting this one on your own, you may try to work ahead. Okay, if you don't feel comfortable, then just wait a little bit, and then you can do it as I do it. Okay, so on this one, go back and think about that very first step. What did that very first step we wrote down today say? Convert, right? Do we need to convert in this one?
Yes.
Yeah, we actually do, right? This. Okay. I can use my calculator to help me if I can't do that math in my head. 15 times 11 plus the numerator, so 173. Okay, so that's going to convert to 173 over 15. Okay, that was the only mixed number, right?
Yeah.
Okay. Now, let's look at all your denominators. 3, 1, 5, 15, 2. I would like it to be 15, but there's this 2. Can 2 turn into 15? No. So then what does it have to be if it can't be 15? What's the next multiple of 15? 30, right? Can they all turn into 30? Yeah. Okay. So we're going to now go ahead and multiply every single term by 30. And there's a lot of terms here. Ay, ay, ay. This evil problem with a million fractions. Making us do math. Ugh. Okay. But at least we're going to get rid of these fractions right now, right? Okay, so we're going to do 30 times negative 4 divided by 3. It's negative 40. Don't forget there's an x with this one. Don't forget x or it'll be sad that it gets left out. Okay, 30 times 1 over here. 30 times 4 divided by 5. It's 24. Yeah, because it started out a negative, right? Okay. Over here, 173 times 30 divided by 15. Ugh, 346. Yeah, I know, huh? 30 times 3 divided by 2. Yeah. Okay. All right. Well, at least this isn't as bad as this one up here, right? Now? True. True that? Okay, let's combine those like terms to keep like making our equation easier to work with. So what's 30 minus 24? 30 minus 24? 6. Remember, these ones are on the same side, so you're not using opposite operations to you're just combining them. Does that make sense? Because they're on the same side of the equal sign. Okay? All right, so now let's get this guy over here. So how do I do that, Damien? I multiplied 30 times 173. And I divided by 15 to get that. Yeah. Does that make sense?
Yeah.
Okay. All right. Can we subtract 45x's from both sides? Don't say this answer is 5 right here. What is that answer right there?
85.
85. It's a negative, right? There's an x there. Don't forget about the x. Okay. Bring down everything else. Okay, what's next?
You subtract 6.
Okay, subtract 6. It's the constant. Okay, what's next? Divide by negative 85, right? Okay, this would be kind of crazy if it actually went in evenly, but I'm going to check before I start reducing if it goes in evenly. Woo! Yay! Okay, so did I even need to worry about reducing on this one? No, because it went in evenly when I checked on my calculator, right? Okay, joy to the world. Okay, now I want you guys to look at how much work this took.
2 pages, 3 pages.
How much was this one problem? Like half a page, right? So, tonight for your homework, I'm expecting quite a bit of work for each problem, okay? There's a lot of steps here. It's a long process. It's not hard, just you have to go through the steps, right? Okay, so your homework tonight, it's on Google Classroom. Okay, it's the C1 homework page. You're going to do numbers 1 through 99, all.
1 to what?
99.
There's 99?
And they're all this much work.
Oh.
Okay, I'm just kidding. Okay,
You think it's 9?
1 through 11.
That's still high. Yes.
Wait, it gets better. Wait for it, wait for it.
Odds.
That's
Odds.
only 6 problems.
Okay. Now, how many total problems is it? 1, 3, 5, 7, 9, 11. 6 problems, right? So, here's the thing. I'm giving you guys less problems because I want you to do a good job. I want you to do the steps and show the work, okay? You cannot turn in 6 problems with no work and then expect to get credit for your homework, okay? It's 6 problems. We're doing a good job showing all the steps, showing all the work, okay? All right.